Hello, my name is Samu Rautiainen and I am from Tampere University and I will introduce you to our component M2O2P, which is an acronym for Multi-Modal Offline and Online Programming Solutions. M2O2P enables human-computer interactions and can be used but is not limited to human-robot interactions. The component uses natural human actions as input, which are in this case hand gestures made with sensor glove. Application connects to other components via firmware and additionally via robot operating system 1 and 2. Next about the software architecture. Sensor glove is connected to Windows 10 PC via Bluetooth and sensor data is read with Captograph SDK. The data is sent via TCP/IP connection to application controller, which is, and all the other parts of the component are deployed as Docker containers. Application controller talks with other containers with ROS2 as middleware. Flask server serves a purpose as main user interface for the component. Since the component is firmware compatible, there is a bridge needed between ROS2 and firmware. This bridge handles bidirectional communication between M2O2P and firmware. Since the component uses ROS2 as middleware, the output can be achieved also via ROS2. Using eProsima's integration service as bridge, the same information can be forwarded to ROS1 topics. M2O2P interacts with firmware, and firmware acts as a middleware between SHOP4CF components. In practice, this means that all the components are connected to firmware and have common language by the data models introduced by the project. User interface of M2O2P offers three main sections. Monitor section has three parts. The application controller output shows important information about application controller, for example updates on firmware and prompts about gestures done at runtime. When the component gets a task, it is updated to process log. Process log has time when task was received, the task name and the gesture that needs to be done. Chief presenting the hand gesture is presented below. If we now make the right gesture, log will ask to hold the gesture for sending the command, and then the task will be completed. Now we got a new task. Process log offers also a possibility to pause the task using the play pause button. Using the task completion manually, we are able to complete the task from UI. If we then scroll down, we find ourselves in calibration section. This calibration table holds the upper and lower thresholds for each finger, and the option to change them. It also provides a way to handle the limits by returning, updating and restoring them. In testing section, the user is able to enter testing mode, which means that gestures can be tested and tried to be replicated. Below the table, the gesture that is picked from drop-down menu is shown. Here you can see a demo where the user successfully made the right gesture. At last we have additional options. This includes switch filtering mode option. If filtering mode is on, the gestures are filtered by the task. M2O2P has multiple different scenarios where it can be used and where it fits. It can be used to control any firmware or ROS1 or ROS2 compatible application or device. It can be used to complete tasks with the glove when the other input methods aren't reachable. And it can be also used to give commands without getting out of focus from the workspace. That is all for now, so thank you for watching.